Hello, and welcome to Lesson 1-1. This is titled, Where Does the Time Go? It can be found on page 3 of your textbook if you're following along. This section will be teaching us all about how to do percentages, pie charts, and bar graphs. So we're going to work through the class section together, and then when you meet in your Zoom section or wherever you meet face-to-face, you'll work on the group work together. At the bottom of page 3, they give us this table. And this table is showing us where our student spends their time every week. So you see that they tell you what the labels are. C is for time in class, H is for time in homework, S is for how much they sleep, work is for work, W is for work, and O is for other. If we turn to the next page, they have been kind to us and have counted up all those numbers, so we don't have to go through and count them up. So what we discovered is that we found out that our student spent 15 hours in class, 32 hours doing homework, 54 hours sleeping, 15 hours doing work, and 52 hours doing other things. So number 1 asks us how many hours were spent in class. That's that first part of the table, and that's 15 hours. And then they ask how many hours were spent on doing things other than classwork. Or other than schoolwork. Sorry, I read that wrong. So other than schoolwork. So we want to add all these up and then subtract out the homework. Or we can just add the other ones and not add the homework at all. So we have 15, I just got to clear that. 15 plus 54 plus 15 plus 52 gives us 136. And then I'm going to write that down for a second. I'm going to talk about one other thing I should have crossed off. Class time would also spent as schoolwork. So we're going to go ahead and get rid of that one too. So I can just subtract 15 from 136. So take your 136 minus 15 and you get 121 hours. So our student spends 121 hours doing things that are not related to school. Number 2 asks, without adding the hours in the table, how can you decide what the total number of hours should be? Any guesses? Well, we know there are 7 days in a week, and how many hours in a day? 24. So if I take 7 times 24, that should give me the total hours in a week. So 7 times 24, 168 hours in a week. And then the author asks us to check and make sure that he added them all up correctly. So we take the 15, the first row of the table, plus 32, plus 54, plus 15, plus 52. And we did it right. So our author was fine. They have the correct number of hours in a week. Number 3, we are still on page 4. Number 3 says, most college advisors will suggest that students allow 2 hours of study time outside of class for each hour spent in class. Is our student doing that? Well, there's time in class from the table in number 1 was 15 hours. We want to multiply that by 2 because that's what the recommended study time is from advisors. That gives me 30 hours. Next, let's look back up at our table. Our students spent, let's get rid of what we had crossed off before. We don't need that crossed off anymore. Our students spent 32 hours doing homework. So our student is meeting the recommendation from their advisor. They're actually doing a little bit more. Towards the bottom of this page, they get into an explanation of what it means to be a percent or a percentage. The word percent literally means per 100. Think about the word cent. Cent means pennies, and there are 100 pennies in $1. So they give an example. If we spent 42% of our time playing a new game on our phone, that means that for every 100 hours, we're spending 42 of them playing this new game. And I know I was a big Candy Crush fan once upon a time, so I totally understand that. Number 4 says, write a fraction with the number of hours spent by our hypothetical student in class in the numerator and the total number of hours in the denominator. So question 1 was the number of hours in class, and from the table in number 1, that was 15 hours. The total number of hours we calculated in number 2, that was 168 hours. And that's all they want for number 4. They want you to write this as a fraction. Number 5 describes how to convert that into a percent. So we're going to use a calculator to do the division. It's kind of a two-step process. We are going to take 15 divided by 168, hit enter, and that gives us a decimal. That gives us the decimal 0.089. Make sure I rounded that correctly. Yeah, the number after the 9 was a 2, so the 9 stays a 9. So we've done the work on our calculator, and this is the decimal. To turn that into a percent, they tell us to move the decimal 2 points to the right. That is one way of doing it. We can move our decimal 2 places to the right, and that gives me 8.9%. Another way you can think of that is you could take 0.089 and multiply by 100. That will also give you 8.9%. So our student spends about 8.9% of their time in class. Top of page 5. It says use the steps described in 4 and 5, so learning how to write the fraction and turn that into a percent, to fill in the chart with the percentages of the hours in a week devoted to each activity. So classwork we already did, and we got 8.9. They do tell me here to round to the nearest percent. Make sure on homework and any work you do, tests, that you look to see what they're asking you to round to. That's going to be a pretty big portion of this class. So we had 8.9%. That is closest to 9%. These are all percentages. I'll put my little percent sign up top. Let's do the same thing for homework. Homework was 32 hours. And we have to divide that by the total hours in a week, which is 168. So we'll pull out the calculator and take 32 divided by 168. And I get 19.190, which is 19%. Do the same thing for sleep. Sleep is 54 hours divided by 168. So 54 divided by 168. If I move my decimal 2 places to the left or to the right, it gives me 32%. Work was 15, which was the same as class, so I already don't have to do that one. I already know it's 9%. Other is 52 divided by the 168. So 52 divided by 168. 0.3095. If I move my decimal 2 places to the right, I get 30.9. So that's going to round to 31%. Now, I've got all those percentages. What should they add up to? They should add up to be pretty close to 100. Maybe off a little bit because of our rounding. 9 plus 19 plus 32 plus 9 plus 31. Hey, we hit it exactly. So our rounding did not mess us up too much. If you're in the right ballpark, that's fine. If you add them and you get 99, 98, 101, that's okay. Because rounding may cause those issues. Oops, I don't know why I did that. Number 7, studies have shown that college students get about 6.5 hours sleep per night on average. But the academic achievement improves when students average 8 hours of sleep. What percentage of hours in the week would be devoted to sleep if you got 6.5 hours? So if I am getting 6.5 hours of sleep per night, and we know there's 24 hours in a day, I can do that on my calculator. I can take 6.5 divided by 24 hours in a day, and I get about 27%. Try to see what they round to. They rounded to the nearest whole as well on this one. So about 27% is how much I'm getting. If I do 8 hours a day, 8 divided by 24 equals 33.3, and they did round it to the nearest whole again, so about 33%. So we've answered the first couple parts of this. It says, how do you think our friend from question 1 is doing? Well, the percent that our student got was 32%. So they're pretty close. They probably could use an extra little bit of sleep per week, but they're getting pretty close. 8 is where we get into something really important. This is on page 5 still of the textbook, and it talks about a circle. There's a lot of information packed into number 8. A circle is divided into 360 degrees. So if it's ever icy out and you do a complete spin, that's called a 360. If you ever tell someone you're making a change in your life, please don't tell them you did a 360. That means you're right back where you started. If you want to tell someone you're changing things, you did a complete 180. But in a circle, there's 360 degrees. This is going to be important. This is something you will absolutely have to know. They want us to convert our percents that we got in number 6 into degrees. So they tell us even how to do it here. They say multiply the decimal form by 360. So my class work was 9%. That was 0.09 times 360. Sometimes I just don't like having all that stuff on there. 0.09 times 360. And they're asking me to round to the nearest whole degree, so that says 32.4. My nearest whole degree is 32. Degrees, these are all measured with the little degree symbol. I also remember that class and work were the same, so I'm going to go ahead and put 32 in for work as well. And then homework was 19%, so 0.19 times 360. 0.19 times 360. Touchscreen calculators can be frustrating. 68.4, so the nearest whole number is 68. Sleep was 32%, so 0.32 times 360. 0.32 times 360. Like I said, touchscreen calculators. You will not have this issue with your handheld one. I get 115.2, so the closest degree is 115. And then the last one, other, is 0.31 times 360. So 0.31 times 360 gives us 111.6. That rounds to 112 because the 6 tells us to round the 1 up. So this is going to be 112. Now, what should these add up to be? They should add up to be pretty close to 360. So let's see how close we were. 32 plus 68 plus 115 plus 32 plus 112. 359. I'm happy with that. That's close enough. It's because of the rounding we're doing. We did a lot where we rounded a little bit lower. It had a decimal point, so I'm good with that. All right, we're going to use these percents from number 8 to create a pie chart. A pie chart is a diagram used to compare relative sizes of different parts of a whole. And you will see here that they kind of give you an example here. This is a solved example, so we'll go through it a little more quickly since it's already done for you. This is an example of a different survey. They asked students they asked people if they washed their hands after using the public restroom. 70% said always, 29% said sometimes, never was 1%. So they walk through what we just did, converting the percent into degrees. So for the always, it was 0.70 times 360, which gave us about 252 degrees. That's the big green part of the pie. 29% of 360 is 104. 0.01 times 360 is about 4 degrees. So after they did the big green part, they went from 252 and then added on to that to get the red pie, and then the rest that was left is the never. So it's an example of one. We're going to do one now. This is going to use our table that we had on page 5, but we're on page 7 to build the pie chart. The nice thing is each of these little lines are 10 degrees. They also have 90, 180, 270, and, well, back to 0 marked for you. So I'm turning my page back to number 5 so I can see my degrees. We always start with a line from 0 to the center. That's my starting point, and I do not do lines well. So if you don't write straight lines, you're right in the same boat I am. We know that class was 32 degrees, so I'm going to start at 0 and count 10, 20, 30, and go a little bit past 30, and that's 32. And that is our classwork. I'm going to get a different color out here. We know that homework was 68%, so I'm going to add 68 to 32, which gives me 100. So that's an easier one for me to graph. It's one line past 90. And that was my homework time. You notice I did not go back to that 0. I always add on to where I just left off. So for the next one, the sleep one, we are going to add on to 100. We're going to add 115 degrees to 100. Feel free to use a calculator for any of these addition problems. This should be 215. So I go to 180, 190, 200, 210, and it's right between 210 and 220. That's my 215. And that was our sleep. I'm going to pick up where I left off for the next one. The next one after sleep was work. That's 32 degrees. So I'm going to add 32 degrees to my 215, which gives me 247. So 220, 230, 240, almost to 250. And that is my 247. And that was our work time. And then the rest of the circle is spent on other. Because if I added 112 to 247, I'd get to 359, which is pretty close to 0. So this is a quick visual of what the data showed us. Your graph does not have to be any fancier than this. This is perfectly readable and it works beautifully. Number 10 asks, does the pie chart make it easier to analyze the amount of time the student spends on each activity? And I would say absolutely, because it's very visual. I can look at that graph real quickly and say other and sleep are the two biggest time things we have. I can say that class and work look to be the smallest. So it's very, very visual. You can definitely see what's happening here. Towards the bottom of this page, they have a nice purple box. Purple boxes are always important information. They are things that you might want to look at more closely. This one's telling us how to draw a pie chart. For number 11, you are likely to do this as a survey in your Zoom sessions or your classes if you're face-to-face. But let's give you some numbers just so you have them in case you don't, or in case you want to work on it and practice it yourself without the numbers from class. Let's say we did a survey in the class and we had 3 people who loved math, 5 who liked it, 5 who could take it or leave it, 7 who didn't like it, and 2 who hated it. So the first thing you need is your total. You have 8, 10, that's a class of 22 people. And that's all the information you need. You would next find the percent, and then you'd find the degrees, and then you could draw a pie graph from that. let's say we did this other one again. You may do this other one as a survey with your groups, but let's give you some information. The difference between the first chart and the second chart is in the first one, you can only vote once. You can't love math and hate it. You may feel like you do sometimes, but you really can't. You have to pick one. In the second graph, we can vote more than once. So it'll be more than the total number of people in the class. So let's say we did the survey, and in our class of 22 people, we had 15 who lived with their parents. We have 21 who work and go to school. We have 3 who have children. We have 16 who are taking more than 10 credit hours. I write too big for these. I'll try to write arrows. We have 8 who started college right after high school. We have 9 who at least one parent attended high school. We have 15, try to make it a little closer to where my line is. We have 15 who drive to class. Born with the year of the 1, we only have 6 of those, and people who know what their major is, we're going to have 22 of those. We're going to say everyone knows what their major is. So these are just some numbers that if you don't do in class and you want to practice doing the group work with these numbers, you're welcome to do them. I hope you enjoyed this section, and I hope you have a wonderful week, and I hope you really enjoy this course. It's definitely my favorite course to teach. Have a good week until next time.